Hello everyone, welcome back again to my channel. Today we are discussing the exercise last but one part of the number system, that's 1.5 exercise. I am providing the solution of to that particular exercise today. Let's get started without wasting our time. The first main itself suggests that rational or irrational. Classify the given questions into its whether it's a rational or irrational. See, I have noted down all the questions here, and let's start the solution. Here the first question is 2 minus root 5, and we know the value of root 5 is approximately 2.2360. This is the value of the root 5, approximate value of the root 5, and this never stops, this continues, this is going to be continuing because it's a irrational number. Root 5 is a irrational number, and if we add any rational to irrational, it gives irrational only. Here we are adding 2 for the negative of root 5, that is 2 minus 2.2360, which gives you 0.2360, and this is continuing. And you know, if the point is continuing, if we numbers repeats, we represent it by a bar, and if that is continuing, that's not a that's not a rational number, that's in the form of irrational. Why? Because we cannot write such number in the form p by q. This is a irrational number, and we see the sign is negative. Why? Because we are subtracting small number with large number, and this is a irrational number. That's why we classified the first one as irrational. Second one, here please notify the thing is, just because they have given a bracket, that doesn't mean this number is multiplying with this term. You should notice the sign present in between the two terms. That sign is very valuable in mathematics. That gives your answer whether it's correct or not. That should be your first step, to notice the sign within the or outside the bracket. Now if we look at this question, this particular question, we notice that this is not going to multiply with the first term, and there is a negative sign between those terms. This is simply nothing but root 3 minus root 23. As simple as this. Why? Because there is a negative sign. If there is nothing here, we can multiply this to each term, and that's going to give you a different answer. Here this is the thing, and you know, plus root 23 minus root 23, both are same. That's something like 3 plus a minus a, going to cancel. This is to show you answer is 3, and we know 3 is not going to continue. 3 is an integer, natural number, and this is going to give you a rational number. Why? 3 can be written in the form 3 by 1, which is in the form p by q. This is going to be rational number. Now coming to the third question. Third question is so simple when compared to first and second question. See, you can observe here, in the numerator of a third question, 2 is multiplied to a square root of 7. In the denominator, 7 is multiplied to a square root of 7. This is simple. I will write for a reference once again. 7 root of 7. Now this is going to cancel. Why? Because they are same. We are left with 2 by root 7, and 2 by root 7 is a p by q form. P by q form. Here also this is for explanation. P by q form. This is going to give you a rational number. Yeah, I believe you are getting the point. Now fourth question. See, if this is in such form, we cannot directly say whether it's a rational or irrational, so you need to rationalize the given number. See, we discussed in the exercise 1.5 how to rationalize. Even this question also discussed. Multiply both numerator and denominator by root 2. Multiply numerator denominator by root 2. This is reference. Now 1 by root 2 multiplied by root 2 into root 2. Root 2 into 1. Root 2. Root 2 into root 2, which is 2. And root 2 is you can, if you need to get to know the some values such as root of 2, root of 3, root of 4, root of 5, which will help you for solving this question particularly. Here you need to know about root 5, here you need to know about root 2. This will help you. We know root 2 is going to be 1.414 continuous, and this is irrational. Therefore root 2 by 2 is also irrational, which gives you this value, and this is totally going to be irrational. Now moving forward to fifth question. Here they have given 2 pi. We know pi value is 22 by 7. It is also 3.14 something something something. Now pi is irrational. Multiplying 2 with pi, which also gives you irrational, and that's going to be 6.2830, which is irrational number. This is the thing of first lesson, first main. Now moving forward to the next. The second main deals us, the question is to simplify. Second main question is to simplify. They have given some simplify. Now first question. The first question itself is something like 3 plus root 3 2 plus root 2. Now here, see, we know here there was a negative sign between the two terms. Here there is no negative sign. This is something like first term multiplied by second term. We know how to multiply polynomials or such two terms. Now multiplying, take first number. I will show you, please give your concentration. Take first term, multiply by whole term. Take second term, multiply by whole term. Take first term of the first is, that is nothing but 3 into 2 plus root 2. First term of a first term multiplied by second whole term. Now here there is a positive root 3, second term of a first term into second whole term. This is something going to be like 3 to the 6 plus 3 into root time, that is 3 times root 2, plus root 3 into 2, that is 2 times root 2, root 3, plus root into root, that's not going to cancel. If there was a root 2 into root 2, then it's going to cancel, because there are two different numbers. We are going to multiply them with a single square root. 2 3 is a 6, and this is going to be your answer. We cannot add these two because the number within the square roots are different. See, I will show you something. Please note this. If root 2 into root 2 going to give you 2. Anything root a in general, root a into root a going to give you a. Why? Because a into a going to be root of a square, square and square root get cancels and give you a. And if there are fine, if the two terms are like, in the sense if this is 3 and this is also 3, this is different. If both are same, then you can add those things, or else you cannot. This is our first question. Second question is 3 plus root 3 first term multiplied by 3 minus root 3. So going similarly, 3 into whole term 3 minus root 3 plus root 3 into whole term 3 minus root 3. 3 3s are 9 minus 3 times of root 3 plus 3 times of root 3 minus root, see, same number, 3 root 3 into root 3, 3. This is going to cancel, they are same terms and with opposite signs. 3 times of root 3, 3 times of root 3 with opposite sign going to cancel. 9 minus 3 going to be 6. See, if you are good with some formulas, you can recognize here itself. This is of the form a plus b into a minus b. A remains same, this number and this number is same, this number and this number are same. If you write with formula, let me write here, this is or second type, a square, see, I will write the formula here, a plus b into a minus b gives you a square minus b square. Same thing, what is a here? 9. A is 3, a square is 9, sorry, a square is 9 minus b square root 3 square, that is square and square root cancel 3, and that's going to give you 6. A square is 9, a is 3. I hope you got. You can do with formula or you can do with multiply. If you do if you are multiplying, then you should take care of the signs and you should take care of the like terms. Because of like terms we can cancel each other. If there is a 2 here and there is a 3 here, we cannot cancel, that's going to be different. Then moving forward, third question, root 5 plus root 2 whole square. So simple, a plus b whole square, a is root 5, b is root 2, a square root 5 square plus 2 a b plus b square. Why? Because the formula is a square plus 2a multiplied by b plus b square. This is reference. Now square and square root get cancelled. The question, sorry, the first term gives 5 plus, here there are different terms but we can multiply because there is no sign between. 5 2s are 10 and 2 times of root 10 is the second term, plus square and square root cancels, going to be 10. 7 plus 2 going to be 7 plus 2 times of root 10 is your answer. Please take a note of all the answers. Practice gives you a good results in mathematics. I am adjusting myself for solving fourth question, and this is the last question for this second main. Fourth question is also a simple one, root 5 minus root 2 into root 5 plus root 2. Sorry, yeah, now you can see. So root 5 minus root 2 into root 5 plus root 2, this is same as we can do with formula method, a minus b into a plus b, which is a square minus b square. A is root 5 whole square minus b is root 2 whole square, going to give you square root cancels, going to give you 5 minus square root cancel 2, going to give you 5 minus 2 3. And please do, once you try with the multiplying method, same, you should get the same answer. You will get a practice is important, remember. Now let me solve the third question. Third question is a not solving question, that's a statement question where we need to solve the contradiction. And I'm going to give you, I'm not going to take something else to prove that. The question is so simple. Let me write here itself. Yeah, question is so simple. Third question. Pi is given as a ratio of circumference to the diameter. C is the circumference of a circle and D is the diameter of a circle. See, this is a circle and this length, the round length, is circumference. You know, this is radius. This round length is circumference and this whole length is diameter. This is diameter, this round length, how much centimeter or how much meter is this, is a circumference and this is a diameter. This is the pi is given as the circumference divided by diameter, but we know pi is a irrational number because the values goes on, so pi is a irrational number. Now is this not a contradiction is the question. Contradiction is the statements are opposed to each other. Is this not a contradiction? We are giving this as a p by q form and this is also this has given us a irrational number. Why? Because this is continuing. And now when we measure a circumference of a circle, we are going to measure with the help of a scale, and scale can give you centimeters. If you measure, scale can give you centimeters, and it can also give you millimeter. It can give you centimeter, it can also give you millimeter, and scale cannot give you more than this. It gives you 1 centimeter, and if you want to get millimeter, 1.1, 1.2, something like that, but it cannot give you more than that. And that is going to the value is going to be, the value which we are measuring in the scale is going to be a approximate value. That's not a sure thing. So whatever we measure is a approximate value, and so the C divided by ratio, the C divided by D, what we get is the approximate value, not the true value, which is not going to be something like this. So this is not a contradiction. This itself is a third question, answer for a third question. And going to the next one, the fourth question is of something where we need to represent the number root 9.3 in a number line, the number system of a number root 9.3 is to be represented in a number line. Okay, now let's take fourth one itself. We are going to represent a number, yeah, you can see it. We are going to represent a number root 9.3 in a number line. We are going to represent a number in a number line. We know if there is a number line, we need to, with the help of a Pythagoras theorem, we need to take a length of which is given, and we need to project that length into a number line. Then we will get the required thing in a number line that we have already solved in our previous lectures. Now we need to select the Pythagoras theorem in such a way one of its sides should be root 9.3, and for that we have a method. For any given large number, large in the sense with something above 5, we cannot do directly, we need to get along with the Pythagoras theorem. So I won't give you with the accuracy, I won't show you accurate answer with the help of a compass and or nothing. I am going to just give you the answers by hand. I will show the diagram just by a hand. You need to do yourself accurately, then you will get the answer. Now let me give you the hint, or let me give you the rough idea to solve this problem. Yeah, if the question is root of 9.3, take a line AB which is of the length of AB is going to be 9.3. This length AB is 9.3. Now what you need to do is stretch this point with 1 unit. This is 9.3 centimeter, stretch again 1 unit. The total going to be 9.3 plus 1, that is 10.3, the total length. See this, let us take this as 1 unit and let us mark this as C. From A to C the length is going to be 10.3. Now this is 10.3. Now exactly point a mark which is half of 10.3. Half of 10 is 5, sorry, half of 10 is 5, and half of 0.3 is something 1.5, 5.15. You need to measure and you need to mark a point of 5.15. Now take this as a radius through your compass and take a semicircle. This should be the radius in your compass, and take a semicircle. This is take a semicircle. I will draw a semicircle. Yeah, see, this is a rough sketch I am going to show you. Take this, measure this O, sorry, this is O, take center as O and C, and put an arc. Now we got a semicircle. This point is B. We know this point is B. Just make a straight line from B. And this should be perpendicular to the line AC. Now simply what you need to do is take this point as D. You should mark every point, that's so important. C, join OD. We will get right angle triangle, which is helpful for calculation of the required length. The required length is 9.3 here, square root of 9.3. We need to make BD as square root of 9.3. Then we project BD to the number line, then we will get 9.3 square root of 9.3. We need to select this and this from Pythagoras theorem such that the BD should be equal to 9.3, root of 9.3. For that, what you need is, we need to measure this length OB. You don't know how much is OB, but you know how much is OC. OC is nothing but OC, length is given like this. OC is nothing but the whole length 10.3 divided by 2. This is the OC. BC is how much? Length BC is equal to 1. If we subtract BC in OC, then we will get OB. See, if we subtract in this full length, if we subtract BC, then we will get OB. OC length on subtracting with BC gives you OB. I have shown this, and this is going to be something like 10.3 by 2 minus 1. See, take LCM and do stuffs. This is going to be 8.3 by 2. How? 10.3 here, multiply 2 here, 10.3 minus 2, it's going to be divided by 2, that's 8.3. 10.3 minus 2, 8.3 by 2. This 8.3 by 2 is nothing but the length of OB. We got OB. OD, what is OD? See, if we have taken this semicircle with the radius OC and OD also a radius of this same semicircle. That is in the sense OC length is equal to OD length. Why? Because both are radius of a same circle. Radius of a same circle in the sense if we measure the radius in any point of a circle from the center gives you the same. So therefore OC is equal to OD. Now with the Pythagoras theorem we know here hypotenuse is OD. OD square is equal to BD square plus OB square. Pythagoras theorem. Remember Pythagoras theorem only for a 90 degree angled triangle, that is right angled triangle. We know OD. What is OD? The radius of a circle. Radius is 10.3 divided by 2, same as OC square is equal to BD square. What is BD? We have found BD. This BD we need to measure, and we need that BD to be square root of 9.3 plus OB square. OB we know we got 8.3 by 2 square. Measure BD square. See, do all stuffs. You will get BD square is equal to 9.3. Just get this thing to here, this term minus these things you will get. Then BD square, if you solve this minus this, then you will get 9.3, and BD is going to be square root of 9.3. If you do this, you will definitely get this answer, square root of 9.3. BD is going to be square root of 9.3, and with the help of a BD, take the BD as a radius, draw another circle which should touch a number line. See, this is the number line. Draw another circle which should touch a number line, and this point is going to be root 9.3. This length is going to be root 9.3. Since this is a result, you can mark this as R, any number from A to R that gives you root 9.3, and hence we represented root 9.3 in a number line. This is something quite big. You need to be good with your concepts, with your basic concepts, or how to approach this question. You need to be good with that content. Now going to the fifth question, let us compart this, separate that fifth main. That is something like rationalize the following. We have seen many examples on this rationalize. First question is 1 by root 7. See, I will give you some tips for rationalizing. If there is 1 by root something, 1 by root a, multiply same thing by root a by root a. You will get root a by, since there are same thing, they will cancel each other and you will get a. This is going to be rationalized form, and this is also of this type. This is going to be something like this, that is root 7 by 7. This is the rationalized form. If you remember this one, you can solve. There is no need to remember all this one. Why? Because you know we need to multiply with the same on both the sides, on both the numerator and the denominator. We will get something like this. If you can remember that, then there is no need of writing this and comparing with this and this. And if you often forgot such how to approach, you often forgot how to, whether we need to multiply or we need to go with something, whether different approach, then you need to remember this one root, which I have written here, 1 by root a into root a by root by. Then you can remember what to apply for which question. That is going to be easy. Even for second question, I will show you something how to approach that going to be easy. This is the easy method I am going to teach you today. 1 is root 7 by 1 divided 1 over root 7 minus root 6. See, take something. If any question given in such form, let us assume, see, there are different number 1 by root a minus root b. Now differentiate here, root a minus root b is minus root b. Now if there is something like this, rationalizing factor of root a minus root b is something root a plus root b. This is the rationalizing factor. This is going to be multiply both numerator and denominator with the rationalized factor. You will get 1 by root a minus root b into, on multiplying with the rationalized factor, root a plus root b. We have discussed this in previous also. Now after doing this, 1 into the numerator is nothing but root a plus root b. Denominator a minus b into a plus b of the form a square minus b square. A square is root a square minus root b square, which you will get root a plus root b minus a minus b. See, if you remember this one, if the question is in the form, you remember this formula, you can solve dead easily. See, if I go on solving for this 1 by root 7 minus root 6, just implement this to this. Root 7 is here root a plus root b is 6 divided by a minus b, 7 minus 6, 1. This is your answer. You can check that also, check by here. The rationalizing factor is root 7 plus root 6. This is going to be 1 by root 7 minus root 6 into root 7 plus root 6 divided by, we are multiplying rationalizing factor numerator to numerator and denominator, root 6. What we get? 1 multiplied by this, that root 7 plus root 6. Here a minus b into a plus b, that's going to be 7 root 7 square, that's 7 minus root 6 square, that's 6. Same, we got the same answer, root 7 plus root 6 divided by 7 minus 1, 6. Same answer. Just remember this. Just remember this for this question, and remember this for this question. Hope you will remember. Going to the third one, there are only 2 more left. Going to be third one, 1 by root 5 plus root 2. Just remember this one. Root a is our 5, root 5, here there is a plus, and see, I forgot to tell something. Here there is a minus, then the numerator is plus. If there is a plus, here the numerator going to be minus. Remember that. Here there is a plus in the denominator, please take numerator as minus, and root b is root 2 divided by a minus b. This is going to be same, that is 5 minus 2. Root 5 minus root 2 going to be same, 5 minus 2, 3. This is your answer. So simple. Fourth one also 1 by root 7 minus 2. See, this also you can write of this form. Here, since there is a minus sign in the denominator, you need to take plus sign in the numerator. Taking this, root a, root 7, here there is a minus, take plus, and root b, there is a root b, and here we have 2. This whole term is, see, this whole term is b, and we have 2 here. So what we need to take is, the second term is b. There is no root here. There is, if there is a root, take root. If there is no root, no root. Then divided by A minus B. A is something. A is 7 minus B is 2 square. Since 2 doesn't have square root, we need to take square, that's 4. Root 7 plus 2 divided by 7 minus 4, which is root 7 plus 2 divided by 7 minus 4. See, please don't confuse here. See, the thing is, you need to, if there is no square root, take square in the denominator itself, or denominator only. There is no need to take square in the numerator. This whole term is just written in the numerator. If this is confusing, you need to take, if there is no square root, need to take square root only in the denominator, not in the numerator. If this is confusing, just go by normal method, which is, I will show that also here itself. I will write again fourth one, 1 by root 7 minus 2. Rationalizing factor is root 7 plus 2. This is rationalizing factor. Now multiply to numerator and denominator. Multiply rationalizing factor. 1 divided by root 7 minus 2 into root 7 plus 2. Root 7 plus 2. This is root 7 plus 2 divided by a minus b into a plus b, that's a square, root 7 square, 7 minus b square. Here, since there is no square root, we need to take b square as like this, and the final answer is root 7 by 2, 7 minus 4, 3. This is your final answer. This completes our exercise 1.5, and in our last session we need to solve 1.6 with small concepts left. Thanks for watching. Please share among your friends and make them to subscribe our channel, so that you can all learn good and have a great basic concept and great grip on a basic mathematics that will help your higher education. Thank you.